Hello everyone. Now in this video we will see how to draw the orthographic projections from the isometric view of a solid. As on the screen you can see the isometric view of a solid. The solid is of a block with a circular hole. The same orthographic projections were drawn in the previous tutorial by the conventional method, generally what we do in the engineering graphics. In this tutorial I will explain you how to draw it using AutoCAD 3D modeling tool. It's a very simple and very faster compared to the conventional one, so that's why I'm doing it here. You can have a look. So now, as explained, the arrow mark represents the front view direction and exactly perpendicular to this one. So this represents the top view direction and this side represents the side view direction. You will have a look. So this one is the front view direction and this is the top view direction and this is the side view direction. So now if you observe carefully, we can see the true profile of this solid in the top view. True profile of this solid in the top view. You can see here this one. So that's why I'm going to start from the true profile side. If you observe in the front side, always you can have a look of rectangle everything, but in the top view you will have a clear look of the true profile. So that's why I'm going to start from true profile side. From here to here the length is 50. From here to here 50 and this one is 60 and from here to here 35 and this is 15. 60 minus 45 15 and this is also 15. 50 minus 35 15 and this one is 45. So now I am going to start in the AutoCAD. Yes, so right now we are in the drafting and annotation layout. So as I said, I am shifting into 3D modeling. Yes, in the 3D modeling, as I said, the true profile can be seen in the top view. I am going to the top view. Okay, take the line, switch on the ortho, 50, 60, 35, 15, 15, 45. Yes, perfectly. I made it in the top view. You can see I made it in the top view. Okay, so now I am going to join it in a single entity. Join. Perfect. Just I joined it. If you observe, this height of the solid is 30 mm. Height of the solid is 30 mm. I finished the top view, length and width, and now I am giving the height. So to do or to give the height, I am changing it to southwest isometric, southeast isometric, because in the question they gave in this direction, southeast isometric. Okay, now using the tool extrude, enter, select this one, enter, height is 30 mm. See, perfectly we did it. The same solid we completed this block, and now we need to make a circular hole at the center. So the dimensions of this one and the location of the center is 25 mm from this side, 25 mm from this side. So what I am going to do is that again move to the top view, take the line, 25 mm, 25 mm. You can change it to southeast isometric. See, 25, 25. Take the circle. Okay, we know the radius is 15 mm. Yes, so it is on the bottom side. Now this is a circular hole throughout circular hole, so that's why take it, enter, height is 30. You can have a X-ray look. See, this is one object, this is one object. To make a circular hole, we need to use the command subtract, enter, from this one to enter. See, we finished this one. You can orbit and check it out. Perfectly we made it. Southeast isometric. Yes, now we completed the isometric view of a solid. So to draw the orthographic projections, here if you observe hidden, there is no representation of hidden lines. So to represent the hidden lines automatically using the software, now I am changing it to layout. Okay, click on the paper first and take the pan command and just move the drawing aside. Click on the model, increase this one. Okay, now to obtain the orthographic projections, again I clicked on the paper layout. Okay, so now go to the layout, right click, always check that it should be in first angle projection. It should not be in third angle projection, it should be in first angle projection. Okay, and now base, from model space, so this is the front view, enter, and this is the top view. Now you can see that southwest isometric, so it's wrong, we'll get a different view. Okay, yeah, see, change, the one what we got is different, so that's why I'm deleting it. Base, model space, enter. See, now we got perfectly the same. So front view, top view, and right hand side view on the left side. So likewise you need to check when you are drawing. So we don't require this one, so just already in the question isometric has given. In the scale I am just changing it to 2:1, bigger one. Here also 2:1, perfect. If you want to reduce, we can reduce to 1.5, it looks bigger. is to, yeah. The same you can apply for this one also. Okay, perfect. Let me draw the reference line. Okay, I am drawing the projectors. Okay, and from here F8, tab 135, perfect. You can check out whether it is in 45 degrees or not. Perfect, 45 degrees only. Delete it. Okay, now intersection points, as already we discussed the same in the previous tutorial. To draw the side view, horizontal projectors we need to draw, and from here first we will draw a line horizontal projector from this side. Okay, from here we need to place it. This one should match exactly to this one. Move, select objects, enter. This portion should be here. Perfect. Yeah, now I am removing the unnecessary portions. Okay, so now from the intersection points I am drawing the projector. See, this one represents a circular hole. You can see, and this one also circular hole. Perfect. Go to the, to give the color, go to the layer properties, so visible line I am changing it to red color. Okay, and for hidden lines I can choose blue color. Okay, yeah, so line weight display on. Perfect. Now you can see, switch off the layer properties. Perfectly we got the front view, top view and right hand side view easily. So now we will give the dimensions. Height 45, ten, 30, 15, 15. This is because of the change in the scale. Sometimes we will get like this. So just we can modify the dimension, otherwise we can change in the scale. So now not an issue. Here we can change the dimension. Sometimes because of the scaling it will change. So this is the 30 mm diameter. And this is 30. Sometimes perfectly will get, sometimes the scale will change. DAL. So this is 30, 30, 15, and this one is 45, 15, 15, 35 we got it, and this is 50. DRA. Okay, this is in block. So simply we can go for the multi-ladder, specify the arrowhead, we can give dia 30. Okay, annotate leaders, modify content, height is very small 5, size 3. Okay, close. In the side view we will get 50. Text, we can write it here, front view, and here top view, and this is right side view, and this is the reference line. Must and should we need to represent x, y, and this is the vertical plane, and this is the horizontal plane. Top view, vertical plane, horizontal plane, everything we mentioned it perfect. So click on the paper. Yes, now with this we perfectly completed the orthographic projections from the isometric view of a solid. So this is using the AutoCAD base model space manager. That's it.